in this circuit it is given that current IA is 2 ampere, and we can see that IA is this current here, and this is a current dependent current source, and the value is 2 IA. So IA is 2 ampere and this one is 2 IA, so this current is of course 2 times 2 is 4. So we need to find out the value of the voltage source. What's the voltage source value? And then we need to find the power supplied by the voltage source and by the current source. These two, the 5 ampere, the two independent sources, we need to find out the power delivered by these two. So what we have here, we have a 5 ampere current entering here, 2 ampere current leaving here, and then this is the node here. So here we have 4 ampere current leaving. So we need to find what is the current through this 10 or 10 ohms resistance. So that's there. So if we write KCL at this point, so we can call this I10 maybe, whatever. So 5 ampere is entering at this node, and then leaving currents are 2 plus 4, and let's say 10 ampere is also leaving. I10, sorry, the current through the 10 ohms resistance is leaving. So what we get, I10 is equal to minus 1 amps. That means the actual current is in this direction, not leaving, it is entering, it has to be. So we have 1 ampere current entering in this direction, and the voltage drop is in this direction. And it's obvious actually, because this current is going 5 ampere here, 1 ampere here, and two outgoing currents are 4 ampere and 2 ampere. Anyway, so the other drop we have across the 30 ohms resistance is 30 is there, and the current is 2 amps. So the voltage here, the drop will be 60 volts. So let me use another color, maybe the green one. So that is 60 volts drop here across the 30 ohms resistance. So I have written the drop there, and the drop across the 10 ohms resistance is in this direction, and that one is 10 times 1 because the current through it is 1, so that will be 10 volts. So if we want to find the voltage source, the value of the voltage source Vs, what we do, we just write KVL across this loop. So across this loop, it's getting a bit clumsy. What I will do, I will erase this one. So this loop, so Vs, so what I do, I go in this direction and I write the drops and rises accordingly. So maybe the rise as positive in this case, because we need to find Vs. So Vs is the rise, and then we encounter a drop of 10 volts because we are going in this direction, so that's 10 volt drop, so that's a negative. And then we encounter in this branch, we encounter a 60 volt drop, so that's also a negative because it's also a drop, is equal to 0. So rises are positive and drops are negative. That's how I have written it. Doesn't matter actually, just we have to be careful about the signs only. And so Vs, I mean signs have to be consistent, that's all. So 70 volt is the value of the voltage source. So that we know. Now we need to find the power delivered by this source. So what is the voltage, what is the current through this power, this voltage source, we need to find out. And that is probably simple because we have an entering current here which is 4, and we have a leaving current here which is 1. So what we notice is the current has to be 4 entering here, 1 going in this direction, so 3 amps current will go in this direction. So the power is actually, this voltage source is actually not delivering power, it's absorbing, because we are getting the power. So basically for a voltage source, the direction, if this is the voltage direction, the current should be in this direction when it is delivering power. But when the current is going in this direction, it is actually absorbing power. So in this case, the current is going in this direction, 3 amps. So the voltage the power that it is absorbing is, let's call it PS, that will be 70 times 3, and that is 210 watt. So we are just saying power absorbing because we have noticed the sign is in the other direction. Now we need to find the power delivered by this source. Let's do that. So we have found the voltage drop across the 10 ohms resistance, sorry, 30 ohms resistance, this one. So this is the drop, 60 ohms, 60 volt voltage drop here. So the same voltage drop will be here because it's in parallel. So the voltage drop across the source, across the current source, is 60. So if we call the current source, let's call it I, Pi. The voltage drop is 60 and current is 5. And we can see that this is actually delivering because the current is going in this direction and this is the voltage. So in the direction there is a rise of voltage, as simple as that. Since it is a rise of voltage in the direction of current, so that's a supply. It's acting as a supply, so it's supplying power. So that's the voltage rise, or just voltage there across the current source, and this is the current of the current source. So this is 300 watt. That is the amount of power delivered by the, so let's say delivered by the current source. So these two information we needed, but we can solve the other powers as well, like the power absorbed or delivered by this one, the independent current source, but I won't go into that. So we have the voltage drops across the registers and the power delivered by the sources. So one is absorbing, the other one is delivering.